So, I am going to talk about dinosaurs, but I'm also going to talk a lot about our ancestry, the mammals that we came from. So what I'm going to do today here is tell you a story, and it's going to be a story of life and death and change and extinction and resiliency, and it's a 325 million year story that I'm going to do very quickly, but a story that should put into perspective how our modern world came to be, our deepest history, and hopefully also give us some perspective for the future. Knowing about the past can help us with the future. So, I'm a paleontologist. I'm one of those lucky people that gets to dig up dinosaurs and dig up fossils for my job. I grew up in the middle of America, but for the last 10 years or so, I've been living and working in Scotland at the University of Edinburgh, and it's a great place for fossils, Scotland, as is Hungary, I should say. And I love to dig up dinosaurs and other fossils. I like to talk about them, write about them. A few years ago, I wrote a book on dinosaurs, a popular science book, and I was very pleased when it was translated into Hungarian, in part because a lot of the book, a big chapter in there, has to do with digging up fossils in Transylvania with a bunch of great Hungarian scientists. And secondly, we have Attila Ursi in the back here, who's Hungary's very own paleontologist. Attila has put this country on the map for dinosaurs. So anything I can do to promote dinosaurs here, I love it. So I will talk to you a little bit about dinosaurs, but I've also been studying mammals, and increasingly I've been turning my attention as a researcher to our ancestors. And I wrote a book on mammals last year, not translated into Hungarian yet, I hope so. But what I'm going to do today is tell you the story of how mammals took over from the dinosaurs. And this was a tipping point in Earth history when that asteroid hit 66 million years ago. But to understand how our mammal ancestors took over from the dinosaurs, we have to go way back in time. 325 million years ago, back to when the Earth looked like this, all of the land was starting to come together, and much of what's Europe today was very close to the equator. So it would have been tropical or subtropical right here where we stand now. And this was the world of the first big jungles in Earth history, but different from the jungles we know today. These were swamps that were full of dragonflies the size of pigeons, millipedes that were bigger than humans, if you can imagine anything so grotesque. And there were trees that were reaching up 35 meters into the canopy, and it's these trees, when they were buried, that turned into the coal that we've been mining for the last few centuries. It's really powered the Industrial Revolution. Now, living in the undergrowth of this jungle forest was a very humble little creature that would have looked something like this. You could have held it in your hand. It would have looked like a little lizardy type of thing. But what it was something that we call a synapsid, and that's just a technical name for a new group of animals that was evolving at that time that was set apart from the other creatures of the day by the evolution of a new feature. And this was a turning point, a big turning point. It was the evolution of something simple, a hole in their head behind their eye. And that's what the arrow's pointing to there. So a hole in their head behind their eye, okay. But what that hole did is it held larger jaw muscles. These things could bite a lot harder than anything around at the time. That was an advantage. And it turned out that everything that descended from these creatures, from that time, 325 million years ago, until today, has that hole in its head behind its eye, including us. So, you feel your cheekbone, and let your jaws roll around a little bit. You can feel your jaw muscles bulging there. That's that hole in the head. There it is. It's kind of merged with our eye socket. The point is, it was these creatures evolving that hole behind their head that set life off on a new path. A humble thing, but it set life off on a new path. And from there was a great division in the family tree of life. One way went the lizards, the crocodiles, the things that would eventually become the dinosaurs and birds. Their lineage split off. The other lineage, with that hole in the head, led eventually towards us, to the mammals. But true mammals wouldn't arise for another 100 million years or so, give or take. And for the next 100 million years, there were a whole bunch of primitive, extinct species proto-mammals, if you will, that were developing features one by one that eventually would culminate in the things that make all mammals today. And it was these early mammal relatives, these early synapsids, that really were the dominant animals for quite a long time, especially in the next interval of time after the Coal Age, was called the Permian period. This is when all the land came together into the supercontinent of Pangaea, one single landmass on the entire Earth, stretching from North Pole to South Pole, and holding dominion on this world. Long before dinosaurs, long before woolly mammoths, anything like that, were some of these early mammal relatives, things like Dimetrodon here. Maybe an animal you've seen before, very characteristic, the big sail on its back, the snarling teeth. It kind of looks like a dinosaur. I think if you showed this picture to most people, they'd say this is some kind of dinosaur. But in fact, it is an early relative, an ancestor of ours. It is more closely related to us than it is to the dinosaurs. This is our deepest ancestry, and these animals ruled the world for quite a long time, until about 250 million years ago, something dramatic happened. And these enormous volcanoes started to erupt in what is now Russia. Surprise, surprise, right? Russia, always Russia. 250 million years ago, today, always Russia. Anyway, these volcanoes were totally out of the scale of anything, thankfully, that humans have ever witnessed. We're not talking about Mount St. Helens, Mount Pinatubo having a little eruption. We're talking about enormous cracks in the earth that opened up and spewed out tsunamis of lava for hundreds of thousands of years. And that lava covered a greater land area than all of Europe put together. But that wasn't really even the big problem. The big problem is when all that lava came up through the earth, it burnt through the Earth's crust, and it released carbon dioxide and methane, the sort of things that we know today are nasty greenhouse gases. And they poisoned the atmosphere. They led to runaway global warming, one of the biggest global warming episodes in all of Earth history, and that led to the extinction of maybe 95% of all species. 95%. But there were a few survivors. And among the survivors were these small little creatures, some of those synapsids with the hole behind their eyes. But these were more advanced ones. They had hair covering their bodies that helped keep them warm. They had bigger brains. They had pretty keen senses. And they were able to dig burrows and hide away during the worst of that carnage. And it was these animals making it through that extinction that then paved the way for true mammals to emerge in the next interval of time as the Earth recovered from that extinction in what we call the Triassic period. The supercontinent was still there, but the volcanoes stopped erupting. The world started to heal. Those surviving synapsids were poised to break out. A new world awaited them, but there was only one problem there. There were a few other survivors, too, of that great extinction, including some small little reptiles. And those reptiles became the dinosaurs. And it was in the Triassic period after that extinction that both proper mammals and proper dinosaurs got their start. Mammals and dinosaurs have the same origin story, but they had very different fates. Dinosaurs were destined for grandeur. Some dinosaurs would become larger than jet airplanes. Mammals had to stay in the shadows. Mammals couldn't get very big in a world with these large dinosaurs. But for the next 150 million years, the fates of dinosaurs and mammals would be forever intertwined. We had ancestors that for 150 million years lived underfoot of the dinosaurs. And these ancestors became what we call proper true mammals. And the first true mammals, things that had hair all over their bodies, that fed their babies milk, that had really big brains, that had great senses of hearing, that had molar teeth, that had only one set of baby teeth, one set of adult teeth, all of the things we think of as mammals today all came together in these small animals evolving at the same time as the dinosaurs. And these things were tiny. They were the size of mice, the size of rats. And this is one of their fossil jawbones down there. That's a grain of rice next to it for scale, just to show you how tiny they were. And really, they had to be tiny in a world where there were enormous dinosaurs. But just because the mammals were small does not mean that they were boring or unimportant or they were failures or anything like that. No. Quite the contrary, as new fossils from northeastern China, the industrial heartland of China, are showing. And these fossils were buried by volcanic eruptions, kind of like Pompeii in Italy, and that locked in incredible detail of the fossils. And they've only been known for a couple of decades, but these fossils show gorgeous mammals of all different kinds. They're all small, these mammals that were living with the dinosaurs. They never got bigger than a house cat, but although they were small, they were incredibly diverse. And some of them were climbers, some of them were burrowers, some of them were swimmers, some of them even glided between the trees on wings of skin. So yes, the dinosaurs kept the mammals small, but mammals, conversely, kept the dinosaurs big. And by that, I mean the mammals, for 150 million years, were so good at being small and adaptable and resilient and living underground, at coming out at night. They were so good at that you never saw a T-Rex the size of a mouse or a Triceratops the size of a rat. You didn't see it because mammals controlled those ecological niches. And that's how things were for about 150 million years. Something of an evolutionary equilibrium. But then once again, there was a tipping point, a huge tipping point, a sudden tipping point. And you can think about it as literally one Friday morning, one random Friday afternoon, a 10-kilometer wide rock falls out of the sky. And the dinosaurs and mammals that were alive then had no idea this was coming. This thing was hurtling through space. It was traveling like more than 10 times faster than a speeding bullet. It could have gone anywhere, right? It was just a piece of space junk. It could have gone anywhere. But it just so happened to smash right into the earth, into what is now Mexico. And it hit with so much force, over 1 billion nuclear bombs of energy were released. And that punched a hole in the earth more than 150 kilometers wide. And you can see some of that still today in Mexico. This unleashed earthquakes and wildfires and tsunamis that reshaped the earth in minutes. And the dinosaurs were at the top of their game when this asteroid hit. They were the dominant animals. But they were so well adapted to their world that they could not quickly change when the world changed around them. And so all the dinosaurs, except for a few weird ones with feathers and wings that we call birds, all the dinosaurs died out, as did 75% of all species. 3 out of every 4 things alive at that moment the asteroid hit, those entire species vanished. But there were some survivors, including some of the small, smart, adaptable, resilient little creatures that had fine-tuned themselves to live in that world of dinosaurs. And of course, I'm talking about our ancestors, the mammals. We had ancestors that stared down that asteroid. And because they were small, because they were adaptable, because they could dig burrows and hide away, because they could eat lots of different food, that was their winning lottery ticket to surviving that sudden period of change. Now, a lot of my work now is studying what happened as mammals took over from the dinosaurs. And we do a lot of work in New Mexico. This is one of the best places in the world in the southwestern US for finding fossils of those mammals that took over from the dinosaurs. And we find quite a lot of fossils. And it's really one type of mammal that started to prosper after the asteroid. And these were the placental mammals, the ones like us that can raise their babies in the womb for a long time and give live birth to well-developed young. Now, in today's world, there's about 6,500 species of mammals, and there's still a few monotremes like the platypus that still lay eggs that harken back to the primitive ancestors of mammals. Then there's some marsupials, mostly in Australia and South America, that give birth to tiny little babies they raise in a pouch. These are kangaroos and koalas and so on. But about 95% of mammals are placentals, like us, like my little boy there, as are all of these things. So dogs and cats and bats and whales and elephants and so on, all placental mammals. It was these mammals that really took over from the dinosaurs. Now, we're doing a lot of work on these mammals in my lab right now. And some of my colleagues, my students, are just leading the way in understanding how these placentals took over from the dinosaurs, how they survived the asteroid, how they prospered afterwards. It turns out it wasn't because they were really smart. So my colleague Ornella here has been using CAT scans to look inside the heads of these early mammals to see what their brains were like. We actually see that after the asteroid hit, the brains of these mammals got smaller relative to their bodies. Intelligence was not the key to survival, but their bodies became so big so fast as they were filling those ecological roles left behind by T-Rexes and Triceratopses and other dinosaurs. So how did these placentals become really big, really fast? Remember, for 150 million years, there were mammals living with dinosaurs, never bigger than a house cat. But what we see in New Mexico is within 200,000 years of the asteroid, there's mammals the size of pigs. Within 1 million years of the asteroid, mammals the size of cows. How did they supersize their bodies so quickly to fill those roles left behind by the dinosaurs? Well, my colleague Greg has been studying the chemistry of the teeth of these early mammals, and we can actually find chemical fingerprints of when these mammals were born and when they stopped drinking their mother's milk. It's amazing. We can see these things in modern-day mammals and their teeth and our teeth. There's chemical signals in our teeth, depending on what we eat. But these things are preserved for over 60 million years. And what we've found is that some of these mammals living right after the dinosaur extinction, the ones that started to get big, they did it because they were able to raise their babies, the mothers, in the womb for 7 months. And then those babies drank milk for about a month, and after that they started eating solid food, and within a year they started having their own babies. So it was the combination of being able to grow for a long period of time safely within the mother's womb. And then once they were born, then they started to develop very quickly outside of the womb. It was that combination that allowed them to get so big. That's really the superpower of placental mammals, and it's one that we retain today. This is the origin of human-style pregnancies. It all goes back to our ancestors adapting and thriving after the asteroid. Now, for the first 10 million years or so after the asteroid hit, there were placental mammals, but they were still experimenting. They were still adapting. But by about 10 million years after the asteroid, we start to see fossils of the modern types of mammals that we all know. And some of the best ones are from not too far from here, a place called Messel in Germany, pretty close to Frankfurt, and it's actually an old abandoned mine. And when the mine shut down, they almost turned it into a landfill. They were going to dump all the garbage from Frankfurt into this big hole. But instead, it became a UNESCO World Heritage Site. Why in the world did that happen? Well, it's because inside the rocks in this quarry are beautiful fossils of mammals. And they're the types of mammals that we can start to recognize. There's horses, there's rodents, there's primates, our early ancestors. These are modern-style mammals. So by 55 million years ago, all the major mammal groups that we know today were starting to proliferate. And mammals were starting to do some weird things too. It was around this time that some mammals turned their hands into wings and started to fly and became bats. And very quickly, bats spread all around the world. Some other mammals started to do something, I think, even more dramatic. And this one was the turning point animal. I think, to me at least, this thing kind of looks like a dog or a wolf, that long snout, those really sharp teeth there. But look at the hands and feet. They kind of look like the flippers of a scuba diver. Well, what you're looking at is the very first whale. Whales evolved from mammals that lived on the land, and they changed their bodies to go into the water. And we actually have a great fossil record, a transitional sequence showing basically how something that looked like Bambi over time turned into Moby Dick. Incredible. We have fossils to show it. And culminating from that are today's whales, including the blue whale, which is the very largest mammal that's ever lived, and in fact is the very largest animal that's ever lived, period, in Earth history, much bigger than any dinosaur. These things are the size of submarines. They're enormous. They weigh like over 100 tons, absolutely massive. And I don't think we really appreciate that enough, that the very biggest animals ever are alive right now. And imagine a world where whales went extinct and all we had were their giant bones. people like Attila and me and others, we'd go out in search of those bones, and people would celebrate those bones, and we'd hold them in high esteem as much as any dinosaur. But whales are not extinct. They're still with us, but they are heavily endangered. So I hope that gives us some perspective. Anyway, so as bats and whales and other mammals are continuing to evolve, the world is not static. The Earth is never static, and the Earth is changing. During the time of dinosaurs, and then for the first 10 million or 15 million years or so after the asteroid, it was a hothouse world, very hot, a greenhouse world. But then the climate started to change, and it all had to do with ocean circulation patterns and the amount of carbon dioxide in the atmosphere. So the world began to gradually get cooler. And as the world got cooler, an Earth that was really dominated by jungle ecosystems, where jungles went all the way up to the North Pole. There were palm trees above the Arctic Circle. That world changed, and those jungles began to shrink in size and became limited to the tropics and the subtropics. And instead, a lot of the jungles in other parts of the world were replaced by a new type of vegetation, a type of plant that had only recently evolved, one that we take for granted, and that's grass. Grass is one of the newest plants on the scene. Brontosaurus, the Stegosaurus, never saw a blade of grass. And about 20 million years or so is when proper grasslands began to spread in many places of the world, including right here, of course. And as grasslands began to spread, and I should say that's because grasses, they grow fast. They're resilient to drought and to cold temperatures, much more than big trees. As those resilient grasses spread, mammals adapted. New mammals evolved to live on those grasslands, especially a lot of fast-running hoofed mammals, things like rhinos and camels and horses. And these things lived all over the northern hemisphere. About 10 million years ago, if you were in the middle part of America where I'm from, which today is a pretty boring place, frankly, back then you could have gone on safari there. There were camels and rhinos and elephants and all kinds of things. And it was the same right here in Hungary. And then new meat eaters evolved, dogs and cats and their cousins, to chase down all that new prey. Now that's what was happening in the north. But there's a whole bunch of other continents down south, which I'm not saying as much about because we're based in the north here. But just to say that down south in Australia and in South America, something different was going on. Australia was isolated from the rest of the world, but South America was isolated then too. It was only about 2.5 million years ago that South America and North America nuzzled together. Until then, for tens of millions of years, South America was an island continent. And on both South America and Australia, it was those marsupial mammals, the ones that give birth to the tiny babies they raise in pouches. It was those mammals that had escaped down south around the time the asteroid hit, way back when. They found themselves isolated on those island continents, and those places became laboratories of evolution for marsupials. And marsupials went mad. In Australia, even until quite recently, there were marsupial versions of dogs and lions and bears. Now, most of these things have sadly gone extinct, but some of our earliest ancestors knew them. Now, that long-term cooling trend really kicked into overdrive about 2.5 million years ago. And that's when the Earth went from this cooling world into a proper ice age. And this is the ice age. There have been a lot of ice ages in Earth history, times when glaciers spread, but this is the ice age, the one they make movies about. And it was then that glaciers, really the ice cap on the North Pole, it grew so much in size it spread down onto the continents. And it would have covered Budapest at times with a mile thickness of ice. And it was in this kind of world where new mammals evolved to adapt to the cold. Woolly mammoths, saber-toothed tigers, the characteristic megafauna, some of the most famous fossils of all, on par with things like T-Rex. And these are mammals that they are extinct now. They died out, most of them about 10,000 years ago. But although they're extinct, they're not mysteries to us because our ancestors knew them. Our human ancestors encountered these megafauna mammals. They saw them, they engaged with them, they hunted them. There are caves across Europe with the first human graffiti in history. Those are drawings of woolly mammoths plastering these cave walls. We knew these animals. We probably played a role in their extinction. Because it was about 6 million years ago, give or take, that some primates living in Africa, as those jungles were shrinking in size, as grasslands were opening up, that some of these primates came down from the trees, started walking on their hind legs, freeing their hands to do other things, to build tools, to hunt. And these were our ancestors. This is when our human line split off from the rest of the family tree of mammals. And these humans continued to adapt, and later on, after they came down from the trees and started walking upright and starting building tools, they started to get much bigger brains. And there have actually been many species of humans that have thrived over the last few million years. It's an unusual world today where we are the only human species left, and our species developed just about 300,000 years ago in Africa. And from there, it has spread around the world and is even starting to go into space. And who knows where our species may go in the future, but as we spread around the world, we are putting pressure on our other mammal cousins. And right now, mammals are in the most precarious position since our ancestors stared down that asteroid. But today, we are the asteroid. We are causing the Earth to change very quickly. But my note of optimism there is that we are a mammal species. We have evolved. We've developed big brains, consciousness, the ability to work together in groups. And these things hopefully will be the key to a better future. So thank you for indulging me on that very quick whirlwind tour, 325 million years of mammal and dinosaur evolution. Very happy to take questions, and we'll do more inside, I know. And of course, if anybody has a book, very happy to inscribe your book too. So thanks again for the invitation. I really appreciate it. Thank you.
Thank you, Steve. Absolutely fascinating.
Thank you, Ian.
Over to the audience, and first question over there.
What are the recent species that could survive a rapid climate change?
Things that are alive today that you think, so you're asking like what kind of species that are alive today might survive rapid climate change? Yeah. So this is one of the reasons we study fossils. I mean, T-Rex, woolly mammoths, they're cool, right? And so the stuff Attila's finding here in Hungary, it's cool, it's neat, it's fun. But the reason scientifically why we're drawn to these things is because they're clues from Earth history that tell us how the Earth has changed over time. And there's lessons we can draw from that. And what we see in mass extinctions in the past, whether it's the asteroid that killed the dinosaurs, whether it's those big volcanoes, we see that it's often smaller species, ones that grow quickly, ones that can hide easily, ones that can eat lots of different foods, ones that are resilient and adaptable. They're the ones that are best able to survive. And it's not a perfect thing, but it's just they have better odds of success. And I think the lesson we can draw from the dinosaurs is dinosaurs ruled the world for over 150 million years. They grew into creatures of incredible size and scale, but they were very specialized to the world that they knew. They had been adapted through natural selection to that world. And when that world changed very quickly, most of the dinosaurs probably were too big. They ate such specialist food. It took them a long time to grow from a baby into an adult. They couldn't hide very easily. That doomed the dinosaurs. But it was our ancestors that were smaller, more adaptable, that made it through. So I would suspect that in a world of rapid climate change, things that are larger are going to have a greater risk of extinction. We're already seeing that, really. So it probably is things like mice and rats and pigeons and cockroaches and all the fun things that we all know that probably have the best chance of survival, those types of animals.
Thank you. Next question.
A couple of years ago, Jack Horner came here to discuss about his project, the Chickenosaurus.
Yes.
My question is, what is the next steps for studying dinosaurs? A lot have been made. Is that kind of project an interesting one for you? And what will be the next steps in that field?
Yeah. So I know very little about this. Attila, do you have any update on the Chickenosaurus? You in touch with Jack these days? I don't know. So Jack, is a great paleontologist. He's retired now, but he was the consultant for Jurassic Park before they hired me to replace him after he retired. One of Jack's things has been this experiment about trying to genetically modify a chicken, basically, because birds are dinosaurs. Birds evolved from dinosaurs. So a chicken carries the genetic heritage of a velociraptor and a T-Rex inside of it. And Jack and his crew have been trying to tweak the genes to make a chicken grow teeth and a long tail and claws and those kind of dinosaur features. I don't know if they're getting very far with that. I don't know how much of it was a real serious, rigorous scientific plan or how much of it was a thought experiment. What I will say is that dinosaurs are still with us. There are still about 14,000 dinosaur species today in the form of birds, more than double the number of mammal species, by the way. So in one sense, dinosaurs still do rule the world. And for me, I appreciate the birds around us. They carry on the legacy of dinosaurs.
Thank you. And I think probably the last question, gentleman here at the front.
And then we'll be inside in a little bit, talking as well, just informally. So please do join us if you have other questions. You can come on inside, and you as well.
I'm wondering what is your opinion about the size, the intelligence, and capability to survive. Mm-hmm. So is there an optimal size of a species or?
Yeah. I don't know. Those are tough questions, and I don't know if there's a single answer. I think when it comes to extinctions and sudden periods of climate or environmental change, normally it does seem to pay to be smaller, to grow faster, to be more adaptable. Having good senses and high intelligence is probably a good thing as well, but as we saw with those mammals after the dinosaur extinction, having really, really big brains and being super smart doesn't seem to have been as important as being able to grow quickly and fill niches that the dinosaurs left behind. So I don't think there's a one-size-fits-all sort of situation here. I think there might be limits to how big an animal can get to live on land. The dinosaurs probably push those limits. Whales living in the water are under a different regime. Gravity doesn't, affect animals in the water the same way because there's buoyancy from the water. Animals in the water don't have to support themselves with their limbs. Over time, whales have gotten bigger and bigger and bigger, almost progressively. So there could be bigger whales in the future. But I think in general, there's a lot we don't know about size, about size, optimum intelligence. We're still discovering a lot of these things.
Steve, thank you very much.
Thank
indeed.
you, everybody.
Please give Steve a warm round of applause. Thank you.
Thank you. And I'll be out here if anybody wants to talk now. All right? Thank you. Thank you.
Thank you, Steve.